Hello friends, so today we are going to talk about empirical formula and molecular formula. So the term molecular formula is already known to you. It means like we are having one molecule of acetic acid. So if I write the molecular formula of acetic acid, what it will be? It will be the number of carbon atom is how much there? 2, so it will be C2. What is the number of hydrogen is there? 4, so H4. And what is the number of oxygen? 2, so O2. So C2H4O2, that is the molecular formula of the compound, that is acetic acid. Now what about the empirical formula? By definition, empirical formula is the simplest whole number ratio of all the atoms present in a molecule. So how to find it out, this simplest whole number ratio? You see, in case of molecular formula, if we try to find out the ratio of different atoms present, so we can see in case of acetic acid, in its molecular formula, the total number of atoms that are present in this ratio 2, 4 and 2. So number of carbon is present 2, number of hydrogen is present 4, and number of oxygen is present 2. So if I try to make a simple whole number ratio, how we can do that? So if I divide all the values with 2, you see I will get 1:2:1. So that will be a simplest whole number ratio. You see, if we try to make the ratio much smaller than this, so it will not come, right? Because already there is 1 has already come. So this is the simplest whole number ratio that we can ever have for this ratio 2:4:2. So that's why this will be the empirical formula for the compound. So there is the carbon is present by 1, so C, hydrogen is present by 2, H2, and oxygen is present by 1, so O. So CH2O, that will be called as the empirical formula of acetic acid. So this is empirical formula. And what was that? That was molecular formula, right? Okay. Now I can give you one more example so that the things can be more clear. Like I am having ethane molecule. Ethane means CH3, that is called ethane molecule. So in ethane molecule, what is the molecular formula of this compound? So there is 2 number of carbon, you can see 1 and 2. So C2, what is the number of hydrogen there? 6, so H6. So that will be its molecular formula, right? Very simple. Now what is the ratio of carbon and hydrogen in that compound? So you see it is present by 2:6. So if we try to make a simple whole number ratio of this, what it will come? It will come 1:3. I am just dividing both the side with the smallest value, that is 2. So I will get 1:3. So it is the simplest whole number ratio that we can have. So that's why the empirical formula will be in that ratio, right? So what will be the empirical formula? The empirical formula will be CH3. It will be the empirical formula. I think the difference between the molecular formula and empirical formula is clear to you. Now if it is clear, then we will discuss about one more point regarding the empirical and molecular formula. You see, in this case, what is the molar mass of ethane in its molecular formula? So there is 2 number of carbon, so each carbon is having the atomic mass of 12. So 2 number of carbon will have atomic mass of 2 into 12, that is 24, plus there is 6 number of hydrogen, and each hydrogen is having the atomic mass of 1, so 6 hydrogen will have 6. So in general, what is the molar mass in its molecular formula? It will be 30, right? In case of the empirical formula, carbon is having 12 plus hydrogen is having more 3, that is 15. Now you see the masses in the molecular formula and the masses in the empirical formula. So these two masses will hold a whole number ratio again, like 30 divided by 15, that is the mass in molecular formula divided by the mass in empirical formula. What it will be? It will be 2. So the mass of molecular formula divided by the mass of empirical formula will again hold a simple whole number ratio, and that value that is coming na, that is 2, so that is represented with n, that is represented with n. So what is the value of n in this compound? For ethane it will be 2 only. In case of acetic acid you can as well find it out, right? So that is a homework, so you just find it out and you will tell me in the comment box what is the value of n that is coming for acetic acid. Now we will write one relation between the n and like molar masses and the empirical formula masses of a compound, and the relation will look like this. So n will be the molar mass divided by the empirical formula mass, empirical formula mass, right? So with the help of this formula, now we will try to solve one numerical. So the numerical is given like that. So you can see there is a problem. In this problem they have asked, determine the molecular formula of the compound with an empirical formula of CH and the molar mass is given. So there you can see the given things are what? Empirical formula, and it is CH, and the molar mass is also given. So you remember what was the formula we have just shown you? The formula was like that, na? N equals to molar mass divided by the empirical formula mass, right? So there you can see the value of molar mass is already given. And what about the empirical formula mass? The empirical formula is given. From the empirical formula, can we find out the empirical formula mass? Yes. So for carbon it is 12, and for hydrogen it is how much? 1. So it is coming like 13. So 13 is the empirical formula mass, and the molar mass is 78. So from this two value, can we find out n? So we can find out n by just putting the value 78 divided by 13, and it is coming how much? 6. So the value of n is 6. So we have to determine what? The molecular formula. How to determine the molecular formula? So empirical formula is given CH. The ratios are 1:1. Now we have seen while determining the empirical formula from the molecular formula, we have just made a whole number ratio by dividing with that n, right? So we are just doing the reverse thing. We are calculating the molecular formula from the empirical one. Now we have to do the opposite thing, that is we have to multiply the values with 6 so that we will get the molecular formula. So 6:6, that is carbon will be present by 6 number, hydrogen will be present by 6 number. That will be the molecular formula of the given compound. I think it is clear, right? So like that, if the value of molar mass and the empirical formula is given, you can easily calculate the molecular formula. So apart from this, there is also few more types of numericals that can come from the empirical and molecular formula, this part. So that types of numerical, that is the percentage composition calculation, that type of numerical we will talk about in the next video. So thank you for watching this video.